Hi, hello children. Hope all of you are staying safe. Shall we start from the last session? In the previous session, we were calculating the HCF of two numbers, isn't it? Now here we are going to find the HCF of three numbers. It's not given in the book. It's not an exercise sum, but you may be getting a question in the board examination. So you should know how to find. Okay. Now first, as usual, you have to select A and B. So here first you can find the HCF of 120 and 48. And then you have to find the HCF of these two numbers with 72. Okay. So you may select 120 and 48, or let us move from the small numbers. What are the small numbers in this? When compared to 120, 48 and 72 are smaller. So let us find the HCF of 48 and 72 first. First let us write what? As usual, Euclid's division lemma. A is equal to BQ plus R. What is the condition? Come on. Yeah, R is greater than 0 or equal to 0 but less than B. Isn't it? And now what? We are going to first step. We are going to find the HCF of 48 and 72. So what will be A and what will be B in these two numbers? A, the dividend will be greater. So 72 will be A and 48 will be B. So you should write A is equal to 72 and B is equal to 48. Now we got to write this A and B in the form of Euclid's division lemma. That is A is equal to BQ plus R. You have A and B. You have to find Q, the quotient and the remainder. So 72 is equal to B into B is 48 into. So let us divide 72 by 48. 48 goes one time. 48. 12 minus 8, 4. 6 minus 4, 2. So children, now what is the portion? Quotient is 1 and this is the remainder. Now, so let us write this, sum 48 into 1 plus 24. Now for the next step, you have to find again A and B because we are not getting the remainder as 0. So this 48 will be A and this 24 will be B. Isn't it? So again we have to write 48 is equal to 24 into. So obviously 48 goes 2 times. In 48, 24 goes 2 times and 0 is the remainder. So we got the remainder as 0. 24 into 2 plus 0. So the remainder or you have got 0. Now what will be the HCF of these two numbers? 24. Now we have to check whether 24 is the HCF of this. What will be the HCF of 24 and 120? That will be the HCF of all the three numbers. So for the next step, A is equal to, now this is first step. Now in the second part, you have to find the HCF of 24 and 120. So what is A? A is equal to the big number 120. B is equal to 24. Now you have to write 120 in the form of A is equal to BQ plus R. That is 120 is equal to 24 into. Divide 120 by 24. It goes 5 times. 5 4s are 20. 0 is the remainder. So 24 divides 120 exactly. That is, it goes 5 times plus 0. So the stops, this is the last step and this is the remainder. What is the HCF? 24. Okay, so now you can say, you can write 24 is the HCF of 120, 48 and 72. So this for when you are finding three HCF of three numbers, you have to do one more step. First you find the HCF of two numbers, any two numbers you can select, and then you find the HCF of that particular highest common factor and the remaining number. So you write the answer. Of 120, 48 and 72 is equal to 24. This is the answer. I think you may have understood by now how to calculate the HCF of given numbers using Euclid's division lemma. So you may be given two numbers or three numbers. It's an application oriented question. So sum number 1 is over, and now we'll move the next sum in the next session. And I have given some practice questions in the description box. You try those sums. If you have any issues, any queries, you just mention in the comment box. So I'll explain it in a particular session. Okay, I am always here to help you children, so feel free to clarify your doubts. Stay safe. Thank you children.